It's a pleasure to be included in this panel. My name is Siying Wang. This study of design approach was motivated by a design studio, where Nano and I discussed the question, how do we know about flood behavior in response to the proposed terrain interventions? The aim of this study is not to examine the precision of existing digital techniques. Rather, we hope this approach can be a starting point to make flood simulation more responsive and accessible in landscape design iterations. This design approach of integrating scenario-based flood simulation was applied to a case study in Kensington Banks, Melbourne. The study area sits within the housing development built in the late 1980s. For a few decades, properties were believed to be secured from riverine flooding. However, that sense of security was challenged after October 2022. The flooded water from river kept reaching inland and overtopping the pathways. 2 years later, the deeper impact came along with new flood maps, where 900 homes were officially reclassified within the 1% annual flood zone. In this context, complexity and multifunctionality of the floodplain system not only require speculative design but also testing. Therefore, this approach first established a baseline alignment across official flood map, hydrodynamic modeling in MACPlus, and real-time simulation in Aerial Engine based on existing terrain. After then, terrain interventions such as levees, fields, and storage areas were iteratively tested in real-time simulation. In this way, Aerial Engine enables repeat testing of creative exploration, offering the better understanding of flood behavior to support design. The final design scenario was transferred back to MACPlus for further testing and validation. Hydrodynamic modeling showed measurable flood depth reductions for up to half meter in the targeted area. As this approach localized the flood simulation to block scale, in this study we also test reconfigured belt form on the altered terrain with attempt to cope with projected population growth. In addition, this approach allows for navigation between trade-offs, testing other strategies. For example, one of the alternative strategies is prioritizing existing architectural style rather than increasing accommodation capacity. This case study investigates the potential of flood simulation as a responsive tool in an iterative design test loop. While the limitation for numerical verification remains, our study demonstrates the prospect of such design approach, and we are seeking to open cross-disciplinary dialogues in the future to discuss its improvement.